We have to learn how to identify terms and coefficients of terms, how to translate word phrases to algebraic expressions, how to analyze problems to determine hidden operations, and how to evaluate algebraic expression.
Algebraic expressions, logical evolution. First of all, we have to talk about vocabulary for algebraic expressions. And then we have to learn how identify like terms and how to combine them. Then we will be ready to learn how to translate English phrases into algebraic expressions. And finally, we will talk again about evaluation of algebraic expressions.
If we have a piece of board, certain length, we don't know exactly length, so we can mark length of this board as an x. Or we can say this positive 1x. If we have another piece, the same length, it will be one more, positive 1x. And one more, positive 1x. So together, length would be positive 3x, or just 3x. If you have another piece of board longer than previous one, and we don't know length, so this time we can mark as a y. It will be positive 1y. If we have one more, we can show one more, and together it will be positive 2y's. Now if we have rectangle, length and width unknown, so we can mark width as a x and length as a y. So it will be area will be positive 1xy. Or cube, length, width and height will be x, y, z. So then volume would be positive x, y, z. And all of those algebraic descriptions of these objects, we would call terms. So 3x or positive 3x is term, positive 1xy is term, positive 2y is term, and positive 1xyz is term. And one more term, just negative 7, just a number. But this time we would call this constant term. Constant term does not have variables. So all of those terms, just descriptions, all of these objects. Now, if we have just terms, now question is, if we can rewrite them together, so it will be first positive 3x and 2y and positive 1xy and positive 1xyz and negative 7. What we have now, it will be algebraic expressions. It will be algebraic expression. So what algebraic expression means? We describe algebraically certain picture. We just describe algebraically certain picture. Definition for terms. The terms of an algebraic expression are those parts that are separated by positive or negative signs. Now we have an example, and this is our algebraic expression. So now let's talk about coefficients. Coefficients, the numerical part of term. So positive 3, positive 2, positive 1, we would call coefficients. And then negative 7 is just a constant term. Negative 7 is just a constant term. Algebraic expressions can be simple and sometimes very complicated. Now we are going to learn how to simplify algebraic expressions if it's possible. Let's look into first term, positive 3x, and then look into second term, positive 2x. These two terms we would call like terms, because definition for like terms is like terms have exactly the same variable part. So as you see, first term has x and second term has x. So now we can combine like terms, means that we can add them. So we can add them physically. Here is 3x and 2x. Together it will be 5x. Or we can add 3x and 2x and it will be 5x. Or we can say positive 3x and positive 2x will be positive 5x. We continue modeling actions for like terms. If we have one more example, 3y one term and then 3y another term. We call them like terms because they have the same variable, y in first term and y in second. And we can combine like terms, means we can add them physically, or we can add positive 3y and positive 3y, it will be positive 6y. One more example, positive 1xy and one more positive 1xy. They are like terms because both of them have x and y variables. We can combine like terms physically, this area and another one. Together it will be positive 2xy. Or we can add them algebraically. It will be positive 1xy and positive 1xy equals positive 2xy. Or we can show as x times y and positive 1xy equal to 2xy. One more example. We have term positive 1xyz and second term positive 1xyz. They are like terms because they have the same variable parts. Each of them has x variable, y variable, and z variable. You can combine like terms physically. You can add them, and we will have positive 2xyz, or we can add them positive 1xyz and positive 1xyz results into positive 2xyz, and shortcut would be xyz and xyz equals 2xyz. Those ones you don't see always them, but you have to assume that they are there. And last example for modeling. If we have two apples, and we can show them as a two weight, and if we have four apples, and we can show them as a four weight. If you combine them together, we will have 6 apples, or we will have 6W. Now, let's talk about second example. Positive 3x and positive 4x and positive 10 and negative 9x. Let's look for like terms. Positive 3x, positive 4x, and negative 9x. They are like terms. We can combine like terms. We can add them. So positive 3x and positive 4x and negative 9x we will have negative 2x, and positive 10, we just have to keep it. Practically, we practice combining like terms. Remember order of operations? In algebra, if we have negative 7 and negative 2 and positive 3, we just need to combine like terms. They're constant term. They're like terms. That's it. Now next example, example number 3. We have negative 7x and positive 2x and positive 3 and negative 6. We can combine like terms, but first let's identify them. So first, negative 7x. Do we have term with x? Yes, we do. And 2x. Negative 7x and positive 2x together will be negative 5x. We are adding the just coefficients. And then positive 3 and negative 6 together will be negative 3. That's it, we're done. Example number 4. If we have negative 3x and positive 10xy and negative 4x and positive 15xy. We want to combine like terms, but first let's identify them. Negative 3x. Do we have more term with x? Yes. Negative 4x. They are like. Negative 3x and negative 4x. We are adding coefficients, so it will be just negative 7x. Next term would be positive 10xy. Do we have term with xy? Yes, we do. Positive 15xy. We are adding 10 and 15. Will be 25, and we have to keep variable part xy. Example number 5. Negative 0.3x and positive 10xy and negative 4x and positive 1.5xy. Let's identify like terms. Term with x. First term and negative 4x together will be negative 4.3x, because we are adding negative 0.3 and negative 4. Next set would be 10xy and positive 1xy. Together it will be positive 11.5xy. Example number 6 is more complicated because we have to see magic number ones in order to read what we have now. Negative 1x and positive 10xy and negative 4x and positive 1xy. After that, let's look for like terms. Negative 1x and negative 4x. Together it will be negative 5x, and then positive 10xy and positive 1xy. Together it will be 11xy. We are adding 10 and 1, and we have to keep variable part xy. And let's look into example number 7. What we have: negative 1x and positive 10x squared y and negative 4x cubed and positive 1xy. Now look into this example one more time, and nothing we can do because we don't have any like terms. We can't combine them, we can't simplify, so we have to keep as it is. In our daily life, we use language which is coming from arithmetic, and now we are going to learn how to translate these English phrases, arithmetic approach, into algebraic expressions. And we have several advices. The first one, use keywords associated with mathematical operations. Word and number, whenever you see word and number, you have to mark as a variable, as a x. It can be another variable, but usually it's x. Now, for addition, word sum, and here is example, the sum of 5 and a number. The sum means that we are adding. We are adding 5 and a number. But practically, in algebra, we will read this positive 5 and positive 1x. Word plus, exceeds, greater, increase by, more than, and total of. All of this for actions addition. For arithmetic actions subtraction, if we have word difference, it looks like we have to subtract something from something. Now here is example. Difference between 5 and a number. Difference, we have to show subtraction, and then 5 and number is variable x. But how can we read this using algebra? It will be positive 5 and negative 1x. Word minus, less, decreased by, reduced by the remainder, and subtracted from. All these words are coming from arithmetic. But I want to focus your attention on word subtracted from, and we'll use modeling. If we have box of 100 apples, and if we have request, take 5 apples from the box. 1, 2, 3, 4, 5. How many are left over? 95. Yes. But look what we did. In arithmetic, it would be 100 minus 5. What we did, we subtracted from. So, subtracted from 5 is becoming second number, and 100 apples is the first. Now, using previous modeling, we can work out request 5 subtracted from a number. So now number would be the first and 5 is second. How can we read this using algebra? Positive 1x and negative 5. For multiplication, the most important word is product. And we can show as a cross. And here is example. The product of 5 and a number. Sure, it's product multiplication, cross, and then we can show 5 and then number x. What will be, or it can be 5x. 5 times x or 5x. In other words, multiply by, twice, times, percent of. All of this for multiplication. For division, the basic word is quotient, which means division. Here's example. The quotient of 5 and a number. Quotient means division, and then 5 is the first piece, and x, which represents a number, will be the second. Or we can show as a 5 over x, because fraction bar means division. For division, we can use word divided by, ratio, reciprocal, or per. Now let's review our understanding for evaluation of algebraic expressions. Here is algebraic expression positive 5x squared and
positive 4xy.
And we have to evaluate for x equal negative 3 and y equal 2. Other words, it can be how much would it be if x is negative 3 and y is positive 2. We have to replace x by negative 3 and y by positive 2. And then negative 3 squared, we have to simplify order of operations, exponents. It will be positive 9, and then multiplication for the 5 is coming from 5 times 9, and then next piece would be positive 4 times negative 3, and then times positive 2. Yeah. And result would be negative 24. Now positive 45 and negative 24 together 21. Positive.